What up, guys? So today's lesson is lesson 1.9, patterns, equations, and graphs. And as you can see, I forgot the 9, so go ahead and fill that in for me. Obviously put your name. All right, 10, all you do, and let's move on to the warm-up. Is the equation 2x plus 5 equals 1 true, false, or open? Explain. Guys, this is an open equation because of the x. Open because of the variable. Okay? Remember, true equations are one where the left side is equal to the right side no matter what. False equations are the ones where they're not equal to each other under any circumstances. And open are the ones that it depends on the variable. So if x was equal to -2, that would mean that we would take 5 minus 4 and we would get 1. So it's an open equation because if x is equal to -2, it's true. If x is equal to 3, then it's not true. Is n equal to 6 a solution of the equation 3n plus 5 equals 22? What we do here, guys, is again, we take this n equals 6 and we plug it right in to our n, okay? So from this equation, we are going to get 3 times 6 plus 5 equals 22. Okay, all I did there was I took our 6 and I plugged it in for where n was in the equation. From this point, we are going to multiply first because of PEMDAS. Our parentheses, yes, we do have them, but the 6 is already in its simplest form. So we're going to move on to exponents. There are no exponents. Multiplication and division, I see one multiplication area, and that's right here, the 3 times 6. Let's go ahead and simplify that. That becomes 18 plus 5 equals 22. And next we can do addition and subtraction because we finished multiplication and division. We move on to addition and subtraction. 18 plus 5 is not 22, it's 23, which is equals to 22. You cannot say that, so therefore this is a false equation. So in the end, our answer is n equals 6, not a solution. And this would be our answer. Okay. Number 3, Molly is making a scale drawing of her bedroom. The length of the room is, make sure you are highlighting the is, 1.2 times the width. If Molly's drawing is 15 inches long, how wide is the drawing? So again, I want us to get used to labeling things using variables, okay? And this problem gives us 2 sets of information. So L, we're going to make the length, and W, we're going to make the width. You could have picked any letters, okay? Just make sure that you're being consistent. So let's figure out the green sentence. The length of the room, so L, is, so we're going to put an equal sign, 1.2 times the width. Okay? So L equals 1.2 times the width. We can go ahead and simplify this further. L equals 1.2 times is multiplication, and W represents width. And then the blue sentence is telling us if Molly's drawing is 15 inches long, so is means equals, it's 15 inches, and at long represents the length, okay? So L equals 15. How wide is the drawing? So we're going to take this 15, plug it in here. And we will get 15 equals 1.2 W. All right, so we found our equation, 15 equals 1.2 W. All right, moving on. identify solutions of a two-variable equation. Is 310 a solution of the equation y equals 4x? So before we were just given the value of one variable, and we were asked to find to see if it was a solution of the equation. Now we're given a coordinate, which is 310, or an ordered pair, and we're asked to find if that is the solution. So you might be wondering, well, how are we going to do this? So what you're going to do is you're going to replace anytime you see x with the first value in the ordered pair, okay? So go ahead and highlight that statement. Replace x with the first value in the ordered pair. And then using a different color, highlight y with the second value in the ordered pair. Is the resulting equation true? So let's go ahead and practice that. So let's take 3, and we're going to plug that in for x, and we're going to take 10, and we're going to plug that in for y, okay? So we get 10 equals 4 times 3, okay? So now 10 equals 4 times 3 is 12. Is this statement true? It is not. False. So what we can say is originally our 310 is not a solution. Okay? So guys, we are looking at two variable equations at this point. The only difference is that the unspoken word, or the unspoken thing about this, is that x is going to be our left coordinate and y is going to be our right coordinate. Okay, it will always be ordered like that. All right, moving on. So is the ordered pair solution of the equation? So we got to test out all of these. So again, this is our x coordinate, this is our y coordinate. So let's plug in 5 for x. Let's plug in 20 for y. Let's see what we get. So 20 equals 4 times 5. 20 equals 20. That one's good. That one is an ordered pair. That is a solution. Let's check out the next one. We've got -5 and -20. So our x coordinate is -5 and our y coordinate is -20. So this becomes -20 equals 4 times -5. 4 times -5, that's going to give us -20. So this one checks out. This one's good. Let's try C. -20 and -5. So our x coordinate now is -20 and our y coordinate is -5. Is -5 equal to 4 times -20? I don't think so. -5 equals -80. That doesn't seem true to me. That one's false. That one doesn't work. And then let's try D finally. So our x coordinate is 1.5. Our y coordinate is 6. 6 equals 4 times 1.5. All we're doing is substituting in 1.5 for x, 6 for y. So 6 equals 4 times 1.5. Let's go ahead and do that. 4 times 5 is 20, so let's put the 0 down there, the 2 up there. 4 times 1 is 4, plus 2 gives us 6. We use this 5, which is the only number to the right of a decimal, so we have to move over one space. So it becomes 6.0. Is 6 equal to 6.0? Absolutely, so D works as well. So 1, 2, and 3 were all solutions of this equation. The only one that wasn't was C. All right, let's move on. So now this is where we are going to figure out, using a word problem, how we can create our own two-variable equation to represent it. So both Carrie and her sister Kim were born on October 25th, but Kim was born 2 years before Carrie. How can you represent the relationship between Carrie's age and Kim's age in different ways? So Kim was born 2 years before Carrie, so Kim is 2 years older than Carrie. So let's start with Carrie's age at 1, and we're going to use a table to help us see this. So when Carrie was 1, what was Kim's age? Kim should have been 3, right? Because when Carrie turned 1 year old, Kim has already been alive for 3 years because she was born 2 years before Carrie. She should always be 2 years older. Let's try 2. Kim should be 4. If Carrie is 3, Kim should be 5. If Carrie is 4, 5, 6, 7, 8, 9, Carrie should be 6. Kim should be 6. When Carrie is 4, when Carrie is 5, Kim should be 7. When Carrie is 6, Kim should be 8. And let's keep going. You guys notice the pattern, so do I. Could we write an equation to compare Carrie and Kim's ages? We absolutely could. So let's use X to represent Carrie's age, and let's use Y to represent Kim's age. So every time Carrie is a certain age, Kim is always 2 years older, okay? So let's say Y equals Carrie's age of 1. So if we're going to start with this 3, right? So 3 equals 1. That's not correct. But wait, if you add 2, now it's correct. So 3 equals 3. Let's try Carrie's age when Carrie is 2. Let's say Y equals X, okay? So 3 equals 1 didn't work, so we had to add 2 on the right, okay? Let's check for Y equals X. Let's see if the second one works. So 4 equal to 2. What do we have to do? We have to add 2 to the right side, and we get 4 equals 4. Okay, let's try one more. See if this pattern is holding up. Y equals X. Plug in 5 for Y and 3 for X. 5 equals 3. If we add 2, 5 equals 5. So it seems like every single time we're just adding 2 to X. So our equation should be Y equals 2 plus X, or X plus 2. I actually like X plus 2 better. Okay. Now, you guys may have seen that right off the bat, that each time that there's a 2 difference, you're just adding to the X value to make it equal to the Y value, okay? All right, let's graph the relationship. So now I've added the table that we just came up with up on the top, and let's go ahead and graph it down here. So we're gonna have to make a portion of the coordinate plane. Oh my goodness, what was that? I wonder if there's a way I can draw a straight line. There we go. That's our coordinate plane, and we're going to bubble in with a different color. So this will be 1, 2, 3, 4, 5, so on and so forth. So when Carrie is 1, Kim is 3. Oops. 1, 2, 3, 4. I'm going to zoom in so we can see. When Carrie is 1, Kim is 3. That's this point right here. Because Carrie's age is on the bottom and Kim's age is on the left. Okay? When Carrie is 2, Kim is 4. Right here. When Carrie is 5, Kim is 3. I'm sorry. When Carrie is 3, Kim is 5. When Carrie is 4, Kim is 6. So let's go to the right 4 units. This is right here. And up 6, we go here. And let's do one more. When Carrie is 5, Kim is 7. So 5, and then we go up 7 spaces. We should end up right here. Okay? Now we have created a bunch of dots, and they are in a line. Okay? So that's how we graph it. As you can see, there's a pattern. So if we were to extend this line going on for a long time, we could find out, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. When Carrie's 15, how old is Kim? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Kim should be 17. Absolutely. Because remember, Kim is always 2 years older than Carrie. So this point, which is 15, 17, is correct. All right. Carrie problem. We labeled Carrie's age for one axis and then Kim's age for the other. All right, so for this word problem up top, I want us to create a table, a graph, and then an equation. So the table shows the relationship between the number of blue tiles and the total number of tiles in each figure. Extend the pattern. What is the total number of tiles in a figure with 8 blue tiles? So in this first figure right here, how many blue tiles are there? There's 1. And how many total tiles are there? Well, I see 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's fill in 9. So for the second one, how many blue tiles are there? There's 1, 2. And how many total tiles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, and let's check 1, 2, 3 tiles in the third figure. And how many total tiles? Well, if you counted them all up, there should be 27. Do we see a pattern? I do. Okay, each time that you are adding a blue tile, you're adding 9 more total tiles. Because when we had 1, we had 9. When we had 2, 9 times 2 is 18. 9 times 3 is 27. Let's move on to 4. When we have 4 blue tiles, we should have 36 total tiles. And when we have 5 blue tiles, we should have 45 total tiles. And this will continue going on. So it's asking us, if we extend the pattern, what would be the total of tiles in the figure with 8 blue tiles? So if we extend this to 8, how many tiles should we have in total? Well, 8 times 9, 72. Okay? All right, so let's create a graph showing this relationship. Okay, so our x is the number of blue tiles. So when we have 1 total tile, we have 2 blue tiles, we have 18 total blue tiles. We have 20, all right? And so now that we've graphed it, x and y, and we already talked about it kind of. We said that every time that we have x, y is going to be 9 times that value, and some values. So let's try x equals 3, y equals 27. So we're gonna switch back and forth between the graph and the table that we just created. So let's go ahead and fill in our graph. Ooh, that was a bad one. Not very good at drawing straight lines, guys. I will get better though. Is going to be this coordinate, or this axis, and our y will be this axis, okay? You always have to label the axes. So you remember, let's do the same thing here. So we've got x and y, tile, okay? We have 9 tiles. So let's make these increments of 3. So 3, 6, 9. So at 1, 9. What else? So let's move over to 2. And we've got 9, 12, 15, 18. Right here. 21, 24, 27. So when we have 3, 7, we move over to the 3 on the bottom on the x-axis, and then up to 27. That's right here, okay? Now, I see a line that we could form, just like that. Okay, so we have graphed it. Guys, you will need at least 3 coordinates graphed, okay, for my liking in order to draw that line. I want us presenting, okay, let's see if they find an equation. So an equation, so we can write it as y equals 9 times x. And we can always, equation is true. So 27 should be equal to 9 times 3. If we do that, 27 equals 27, so we're good. So this equation is our solution, okay? The more we practice these, the more you guys will get better. And I believe, speaking of practice, yes, you guys have some practice problems. So I want you guys to give those a try before you finish watching this video, and then you can watch the video for the solutions, okay? So now that you've tried the questions, is 2, 4 a solution of the equation y equals x minus 2? So this is our x, this is our y. Let's plug them in. So we've got 4 for y equals 2 minus 2. Is 4 equal to 0? Absolutely not. So 2, 4 is not a solution. Okay, next 5 practice problem. 1, is -3, -9 a solution of the equation y equals 3x? Well, let's go ahead and check it out. -3, -9, this is our x, this is our y. -9 equals -3, I'm sorry, it should be +3. And then x is -3. -9 equals 3 times -3, a positive times a negative. When you have different signs, you are multiplying. That is always going to be negative, and it's -9. Absolutely. So -3, -9 is a solution. Why? Because when we plug it in, it is a true equation. This problem, there's 4. All right, so drinks at the fair cost $2.50. Use a table, an equation, and a graph to represent the relationship between the number of drinks bought and the cost. So we have to make our own table. Oh, geez. Here we go with straight lines again. There we go. That's better. So drinks at the fair cost $2.50. So let's do cost on one side. And let's do number of drinks. Okay, so if the cost is $2.50, how many drinks did you buy? 1. Let's go to 2. If you bought 2 drinks, how much would it be? It would be $5. If you bought 3, it would be $7.50. If you bought 4, it would be $10. And so on, okay? So now let's go ahead and graph it. Let's graph 3 of the points. And remember, guys, when you are graphing, you can make whatever you want, whichever axes you want. So you could make the cost here, or you could have made it the other way around. And we'll make this the number of drinks. This axis, okay? So, and you can also change the increments that you go by. So the number of drinks, let's say we want to make this one 1, 2, 3, 4. We can make this one 2.5, 5, 7.5, as long as it's consistent. So each time we're going up a unit, it's going to be 2.5 or $2.50. So that way we get from 2.5 to 5, because 250 plus 250 is 5. You add 250 to $5 and you get $7.50. Then we can make it up to $10, okay? So each time, just make sure that you have a consistent graph. So for 1 drink, we were at $2.50, so that's where we're gonna bubble. For 2 drinks, we were at $5. And for 3 drinks, we were at $7.50. And for 4 drinks, we were at 10. We've got a nice straight line, perfect. We can graph it like that. Okay, and lastly, we need to find an equation, okay? So our equation should be, we have to make a variable for the number of drinks. We can make that n represents number of drinks. Actually, no, sorry. We are going to make X the number of drinks. Let's be consistent here. So X will be number of drinks. And Y will be the cost. So whenever Y, let's say Y equals, we're going to have to find out how much the cost should be for the number of drinks. So in the first scenario, we have one drink gives us a cost of $2.50. So it should be $2.50 per drink. Okay? So when X is 2, 250 times 2, we should get 5. Y equals 5. Absolutely. So we know that our equation is good. So this is our equation. Okay? Because each time X is increasing, you're increasing by 250. So it has to be 250 times X. All right? I want you guys, and practice number 4. On a treadmill, you burn 11 calories in 1 minute, 22 calories in 2 minutes, 33 calories in 3 minutes, and so on. How many calories did you burn in 10 minutes? So let's make a table. Calories, minutes. Okay? So in 1 minute, 11 calories. In 2 minutes, 22 calories. In 3 minutes, 33 calories. I've noticed a pattern. If you guys did as well, that's good. Each time you are burning calories for a minute, you burn 11 calories, okay? So this could be written as, if this is X and this is Y, let's say that Y equals 11X. So if we put in 10 minutes of burning calories, Y would be equal to 11 times 10. And in this case, it would be Y equals 110. So 110 calories is our final answer. All right. Practice problems. If we were to take this one, we didn't know how many calories we were going to burn in 10 minutes. Okay. But setting up an equation, we were allowed to find that. To give those a try. Those were I want to leave you guys with an exit ticket. How is writing an equation to represent a situation involving two variables similar to writing an equation to represent a situation involving only one variable? And how are they different? I want you to think about this one and write down your answer, and then we'll write down my answer afterwards. So how is writing an equation to represent a situation involving two variables similar? So they're similar because we are substituting variables for unknown conditions. Okay, so like, all right, and how are they different from each other? Well, obviously, for starters, two variables, not one. Also, they have a relationship. Okay, with one variable, it was completely dependent on everything else. So you have a relationship with these two, and you can graph them. Because remember, you need two axes in order to graph, an X and a Y. Okay? If you came up with something cool for their differences, go ahead and let me know. That way I can add it. Otherwise, that was everything, and here's your homework. Okay? Good luck. I'll see you guys tomorrow.